Linear equations in one variable. Linear equations have the form ax plus b equals 0, where a does not equal 0. For example, 5x plus 2 equals 3x minus 6. If we start combining like terms and bringing terms together, subtract 3x from both sides, we have 2x plus 2 equals negative 6. Now I could add 6 to both sides and end up with an equation that is in the form that we saw above, ax plus b equals 0. But let's go ahead and solve this and subtract 2 from both sides instead. 2x equals negative 8. Divide both sides by 2, x equals negative 4. So this is one way of writing the solution. You may also see it as the set containing negative 4. So this is considered a solution set. An identity is true for all values of the variable. For example, 3x equals 2x plus x. If I combine terms on the right-hand side, I get 3x equals 3x. If I try to get all my x's together and subtract 3x from both sides, I get 0 equals 0. And this is always true, no matter what value we substitute in for x. Inconsistent. This results in a false statement. For example, 5x minus 15 equals 5x minus 20. If I subtract 5x from both sides, we get negative 15 equals negative 20, which is never true. So this equation is inconsistent. Let's look at solving some equations. For example, 4 times x minus 3 plus 12 equals 15 minus 5 times the quantity x plus 6. Let's start by distributing. We get 4x minus 12 plus 12 equals 15 minus 5x minus 30. On the left-hand side, I'm going to end up with 4x because negative 12 and positive 12 cancel. On the right-hand side, let's combine 15 minus 30. And we get negative 15 and then minus 5x. Let's move all our x terms to the left, so we'll add 5x to both sides. 9x equals negative 15. Divide both sides by 9. X equals negative 15 ninths. We can simplify this by dividing both the numerator and denominator by 3, and we end up with negative 5/3. Sometimes a rational equation ends up being a linear equation in the end when we're solving it. For example, 3 over x minus 6 equals 5 over x. Now before we start solving this, let's look at the denominators and determine what values are excluded from our domain, or what values are excluded from our solution set. So let's set each of our denominators equal to 0. X minus 6 equals 0. Solving, we get x equals 6, and then set the other denominator equal to 0, x equals 0. So x cannot equal 0 or 6. Let's find our LCD, and we do that by looking at our denominators. So we have x minus 6, that needs to be a factor in our LCD. We have x, that's another factor in our LCD. So our LCD is the product x times x minus 6. Okay, let's multiply all of our terms by the LCD. So on the left-hand side, x minus 6's cancel out, and we're left with 3 times x. On the right-hand side, x's cancel out, and we're left with 5 times x minus 6. Let's distribute. But before we do that, I do want to point out that this type of rational equation is special because it's a proportion. We have a rational expression equals one rational expression. So we could have cross-multiplied and set them equal. And if we had done that, 3 times x is our left-hand side, and 5 times times x minus 6 is our right-hand side. Okay, now distributing 3x equals 5x minus 30. Subtract 5x from both sides. Negative 2x equals negative 30. Divide both sides by negative 2, and x equals 15. So let's check. Does 15 equal one of our excluded values? 15 does not equal 0. 15 does not equal 6. So x equals 15 is our solution. Let's look at one more rational equation. X over x minus 2 equals 5 over x minus 2 minus 1/2. Okay, so we have two different types of denominators. Let's set x minus 2 equal to 0 and x equals 2. And x cannot equal 2. We don't need to set 2 equal to 0 because 2 will never equal 0. So we have one excluded value. X cannot equal 2. Let's develop our LCD. So we need to have an x minus 2 as a factor. We see another x minus 2, but we don't need to put another one, so we only need to have one in our denominator and our LCD, and we need to have a 2. So our LCD is 2 times the quantity x minus 2. Let's multiply all three terms by this LCD. On the left-hand side, the x minus 2's cancel, and we're left with 2x. So the first term on the right-hand side, the x minus 2's cancel, and we're left with 2 times 5. And then on the last term on the right-hand side, the 2's cancel, and we're left with minus 1 times x minus 2. Okay, so 2x equals 10 minus x plus 2. That's combining like terms. 2x equals, and then 10 plus 2 is 12 minus x. Let's add x to both sides. 3x equals 12. Divide both sides by 3. X equals 4. So let's check. Does 4 equal our excluded value of 2? No. So x equals 4 is our solution. So if we did end up with a solution or a value that equaled our excluded value, and we had no other options, then we would have no solution.